Good morning, everyone, and thank you for coming. We welcome you to this session, which is about unleash the power of your data-centric applications with HPE and SQL Server. And basically, what we will be talking in this session is all about the collaboration that we are doing with Microsoft to bring, in fact, new innovation to solve the problem of today's world, which is moving to a data-centric environment where data is at the heart of the enterprise. And I'm delighted to present today with several people. So my name is Laurence Grisot, and I'm working for Hewlett-Packard Enterprise Servers. I'm an evangelist in this group, and then Brett will be presenting with me.
Yeah, good morning. My name is Brett Gibbs. I'm the persistent memory product manager, and we're going to talk to you today about our greatest new category in the portfolio, persistent memory, and how we're working with Microsoft to get the applications ready. And I'm going to show you some really cool demos today as well on the type of performance you can expect from persistent memory. Guhan.
So, I don't have a mic, but
There we go.
Hi, my name is Guhan, and I'm a product manager for 3PAR Store Cell Storage from HPE. And today I'm going to talk about how you can make the most out of SQL Server deployments on 3PAR. The features on 3PAR that are going to help you get the most out of it, right? And thank you.
Thank you. So what I'm going to do first is just talk about the data-driven enterprise organization, what it is, and why is it important. And we think this is important just because to bring new value and new business to enterprises, then people must be able to harness their data, make sure that they know where the data is, and then connect the data between them so that we can get the information at the right moment for the right stakeholders whenever there are needs in fact, looking at what's going on, what happens, or what will happen if we do we make some of the decisions. So the idea is to have the right application at the right level of speed in order to ease the decisions that we need to make. The world is moving very fast, and we need to have this fast pace so that we can make the right decisions. So there are studies out there, and then when we ask customers, what are your pain points today? What are you doing if you want to have insights about your data? What does matter to you? And we came to a request, in fact, to use, sorry, I just back up. So we used one of the study where they requested 300 customers to bring their ideas about what's not working. And then people said, more than a half of the people say that if they want to make the right decision, they're lacking information. And if they have this information, it's not coming in time. And then about a quarter of the people said that they can make decisions based on the insights they have from the data they are getting from the various silos, BUs, and so on. So of course, this is due to many factors. It could be that we are using legacy architecture, we are using legacy hardware, and I can switch to the other slide to address the different challenges we have. In fact, it's becoming more and more complex. We have lots of data everywhere. We can have many applications, many servers having those data, but they need all of a sudden to be interconnected so we can have the right information. if we have such a sprawl, if we have acquired different enterprises, then of course we spend a lot of money managing those solutions, maintaining those solutions. And so we want to have something more agile to be able to treat this data. And of course, the technology is helping, and I'm sure that you will be persuaded when you will see what we will be demonstrating what's coming in the near future and how we have enabled the things so that we can empower the business processing, accelerate your analytics, and optimize the infrastructure. So we have a breadth of offering at Hewlett-Packard Enterprise, and I'm sure that well, any of our customers can come with their different needs and constraints, and we will find the right solutions with our partners, with Microsoft. And then here, what we want to show is that if you are running some business processing application, there are different factors that will influence the solution that you will be selecting. The amount of users, the amount of transactions that you need to process, but also how critical is your application that delivers this business processing. If you need headroom, if there is a business that is growing and you know that in the near future you'll have more application and of course more data. And so we tried to put those different factors and give you some ideas of what we can come with in order to help. So Brett will show the great speed of business processing by using persistent memory. I'm sure you will be persuaded at the end. But also when it comes to larger data sets or larger workloads where you have a fair amount of users that needs to process a lot of things, and you need to have a super reliable hardware, then you might have to move to something larger. And we have offerings with 4-socket servers and above. I'll be talking about the SuperDOM-X, which is a great system that offers the mission criticality. It's built into the system. Now, in decision support, there are also some other factors that will influence the choice of the solution. The speed, of course, speed of getting insights from your data. Also, the database size. Well, of course, the flexibility of expanding if you need to expand or interrogate other source of data. And then the criticality is always one of the factors. So again, we'll have solutions. We'll be talking about what we have today. And I just want to give you an overview of that offering. It's just a subset of what we have, but we believe it can probably fit many of the needs that our customers have today, or that you have today. The first one is our 2-sockets server that you can see here with up to 44 cores. And this is where you can have the persistent memory today. So Brett will talk more in detail about that, that really accelerate the amount of transactions you can do. Then going to a larger size of a database, you might, and larger amount of users that will be using the applications or larger applications, you might want to go to a server that has more resources. And this is the case with our 4-socket servers like the DL580 Gen 9 that we offer today on the market. But then it could be, if you want to reach the highest level of mission criticality, then you can go to this SuperDOM-X. Well, of course, data has eventually to be stored somewhere, and Guhan will talk about our free power offering, which offers the great reliability, of course, very good performance, and that fits very well with the environment that we want our customers to have. Now I hand over to Brett.
Okay.
Sorry.
Thank you very much. So again, my name's Brett Gibbs. I'm the Persistent Memory Product Manager. Persistent memory is the name of our product category. It basically describes a set of solutions that have memory level performance, but the attributes of traditional storage. So again, think of it this way. You keep hearing in the industry the convergence of memory and storage. And so this is what this category is all about. So today I'm going to talk to you specifically about our first product in the category, the HPE 8 gig NVDIMM, which stands for non-volatile DIMM. So I thought as a primer it might be good to kind of show you, we've got about a 1.5-minute video that talks about this solution, so bear with me just a second. And I'll get the video going here. All right. So here's kind of a close-up shot of our NVDIMM. So this is the first NVDIMM in the market, by the way, that's designed around a server platform, specifically ProLiant servers. And if you want the long version, there it is, non-volatile dual inline memory module. We have our DRAM up top. This is a NAND flash. This is what provides the non-volatility. Here's our backup power source, the smart storage battery, which is a 96-watt lithium-ion battery. We sit on the memory bus adjacent to the server memory. And I'm going to show you some performance metrics here in a minute that back up that 4x improvement. Looks a lot like a DIMM. It's designed around DIMM technology, but again, the NAND flash is what provides the persistence. Okay. All right, so let's get into this. Let me give you a little bit of primer here. So I mentioned the convergence of memory and storage, and what I'm showing here today is a technology pyramid, starting from the top, the CPU, and moving all the way down to magnetic media like hard drive and even tape. So the further down the stack you go, the longer the latency or the response time. Also, this is traditionally the domain of block stored data, the way applications talk to things like hard drives and SSDs. The further up the stack you move, the lower the latencies, right? So basically the shorter response times. This is also where applications start talking to the media directly, what we call load store or byte addressability. Persistent memory sits pretty much in the domain above flash media, right? So think of the fastest media today, and that's flash-based PCIe SSDs, NVMe SSDs, PCIe workload accelerators, things like that. And then, of course, DRAM is the technology that we have on our memory. So our first product, the 8 gig NVDIMM, as I mentioned, is actually DRAM, right? You're running your applications on the DRAM, and we're using the NAND flash as the persistent store. What you're going to see emerging in the market, especially when you start looking at the next generation of servers, are technology that's, again, sits between SSDs and memory. Not everything is going to run at memory speed. The product that I'm showing today and the demo I'm going to take you through is actually running at memory speeds because it is DRAM. Okay, as I mentioned, we're the first major server vendor in the market to deliver persistent memory. There are other NVDIMMs in the market, so I don't want to confuse the message here. But what we did is we evaluated what was out in the market, and we designed an NVDIMM around the ProLiant ecosystem. So what that means is integration with our management software like ILO, fine-tuning the BIOS. I can tell you that the extensive work required in things like the memory reference code, the MRC code, is it's quite lengthy, it's quite detailed to get storage functionality moved to the memory bus. So it's really important that whenever you're looking at a solution out there, that it is designed around the servers that you have deployed in your data center. We focused in on the DL360 and DL380. These are the Broadwell-based processors, the E5 2600 V4s. Next generation, we're going to extend this. So again, we're focused on the ProLiant DL in this generation. Next generation, you're going to see things showing up on Blade system. You're going to see further extension into the ML and DL ProLiant servers, things like Synergy, things like Apollo. We're going to have it all over the place. So, but our entry into the market is going to be focused in on the DL360 and 380. I showed you a video of the 8 gig NVDIMM, and one of the things here that we did that I think kind of sets us apart from our competitors, we actually integrated the smart storage battery. It provides the backup power directly to the memory slots, and that's done through the motherboard. There's a little pin that comes off the battery, and that plugs into the motherboard. Some of the alternative solutions out there use things like supercapacitors, really cool stuff, but you end up with a lot of wiring, and as you add in new supercaps and new NVDIMMs, you have this tethered effect. I like to call it the Medusa effect, because when you open the server, you've got wires hanging everywhere. And when you get into servers like the DL360, which is a 1U, you have, you kind of have challenges with the airflow and baffles and things like that. All right, one thing I want you to get out of this session today is the software ecosystem is equally as important as the hardware. We love our hardware at Hewlett-Packard Enterprise. We tout it. We stand behind it, but this category, the most important thing as you're evaluating solutions out in the market, are we bringing the software, is the company you're working with, are they bringing this software ecosystem? And that is one of the big areas of focus that we've had, and specifically with Microsoft in a couple of areas. One is we have a Windows Server 2012 R2 driver. We're the only ones in the market with that Windows 2012 R2 support, by the way. Windows, Microsoft actually had great vision on this. Windows Server 2016 has an inbox driver supporting persistent memory. So I think that's really cool, that they're ahead of the game there. Software applications, Microsoft SQL Server 2016. One thing I'm also going to talk to you about today is the fact that applications today can use persistent memory natively without any changes. So it's going to see it as a block storage device, just like it would see a hard drive or an SSD. I'll show you a slide here in a minute how that's going to look. What Microsoft did, the SQL team did, is they realized that, hey, I can talk to this device in a block storage manner, but I'm not able to get all the performance, the full performance potential out of the technology. So what they have done is they've changed their transaction log, specifically the tail of the log, to be able to use this technology in a byte addressable way. So if you have Windows Server 2016, you have an inbox driver support. If you have SQL Server 2016, you're going to have, I'm going to show you here a demo in a minute that will show you the performance potential of talking to persistent memory in a byte addressable way. How fast is this stuff, right? We love to talk about how fast things are, but let's actually look through some numbers here. Left-hand side is our technology performance quants. We took a single NVDIMM and we compared it to the fastest SAS SSD in the portfolio. All right, so we looked at 3 measures: IOs per second, bandwidth, and latency. Latency is really important, and this is where the performance comes in. The more latency you strip out, the faster things can go. 34 times more IOPS, 16 times greater bandwidth, and look at the number for latency. 81 times lower latency than a very fast SAS SSD, so that's pretty incredible. Now, PCIe workload accelerator, think of this as an SSD on the PCIe bus. We're still at 24 times greater IOPS, 6 times greater bandwidth, and look at the latency. The fastest storage available today is flash on the PCIe bus. Persistent memory is 73 times, specifically the 8 gig NVDIMM, 73 times lower latency. So pretty incredible numbers there. That's cool. We love our technology, but let's talk about your applications. That's what you run in your business, and that's the lifeline of your business. So let's take a look at SQL. We looked at SQL 2012, 2014. As I mentioned, no modifications. It's going to see this device as a block storage device. We've seen performance levels up to 2 times faster, and this is using a single NVDIMM moving the transaction log from talking to like a SAS SSD and now talking to an NVDIMM. The byte addressability, this is really where applications are you're going to see a lot more performance. We're up to 4 times faster, and I'm getting ready to show you a demo here in a second to demonstrate that. Okay. I mentioned to you software doesn't have to change to be able to use this, but I think it's also important that you understand why software has to change in order to take full advantage of the performance potential of this technology. This is a busy slide here, but I want you to focus your attention on the left-hand side. This is not representative of any specific application, but what we said is take a typical OLTP database and do a write command. Let's go track the number of commands that have to happen in code and everywhere you have to go. So you have things at the application layer. You have things at the operating system layer, like the drivers. And then, of course, you have the hardware at the end that has to take the commands and respond back as completed. A typical single write to a database can take up to 25,000 code instructions and at least 3 copies of data. And if you follow the, just right there in the middle, you can kind of see where the bottleneck usually resides is the hardware. Hardware manufacturers don't like to admit that, but the reality is today, software is much faster than hardware. Okay? Let's look on the right-hand side. What happens when you change things to be byte addressable? So not only think about your mainstream applications like SQL Server, think about all the applications that you have that are unique to your business and how those could potentially change to take advantage of this. We went from 25,000 instructions down to 3, right? And look on the right-hand side, you've got the application now talking directly to the hardware. You've bypassed the drivers, now you're talking directly to the technology. 3 instructions and 0 data copies, so you get a double benefit here. Not only is your performance going to be greater, you're also going to have fewer lines of software code to maintain. Right, so I know application developers, if you got to go back and say, hey, we're going to go change our applications, they're going to push back and say no. But one of the selling points for them is once this change happens, it's fewer lines of code to maintain. Okay, how is this going to look in Windows 2016? So if you look at the left-hand side, as I mentioned, the driver will see this as a typical block storage device. So that's kind of shown there at the top, where you see SCM block. That stands for storage class memory block. But what's going to happen when you do direct access, or what we call byte addressability, that's when applications are changed to talk to this in a load store byte addressable manner. You're going to see a lot of things going on. So on the right-hand side at the bottom, I want to show you some of the metrics that we did on this. We took a 4K random write operation. Took a single NVDIMM. Thread count is 1, and we ran this as a block device. So very good IOs per second, 187,000, and a latency of 5.01 microseconds. Now look what happened. I go to byte addressability. I go from 187,000 IOPS to 1.67 million IOPS. Same device, same test bed. The only difference is the application is now talking to it in a byte addressable way. And look at the latency, 5.01 to 0.52. So that's almost a 10x improvement in latency. I believe, anywhere you get 10 microseconds of performance or better, you're doing really good. So you can kind of see the level of performance that we're talking about here with persistent memory. Now, let's drill down a little bit further. You came here to hear about Microsoft products. SQL 2016, tell the log. This is the portion of the transaction log where the writes are coming in. So think about all the transactions that have to happen, right? All of those transactions have to be logged. So your transaction log is where most of your write latency is occurring. And the tail of the log is specifically the area as the write commands are coming in. What I'm going to talk here about is a scenario where we compared it to the fastest SSD technology and comparing that to our HPE 8 gig NVDIMM. I've got a DL380 Gen 9 server with both sockets populated. I've got my NVDIMM for the tail of the log. I've got 2 SATA SSDs as the store for the database files, And then I have an NVMe SSD for a store for both logs, and then I'm running 128 gigs of memory. You can see the software, and basically we're doing table inserts in SQL. Look on the right-hand side. The write-intensive NVMe SSD, that is our fastest SSD in the HPE portfolio. We doubled our transactions, and we cut our latency in half. And if you move on down the line, what we did is we took a SAS SSD, and this is where we get the 4x number. Comparing a SAS SSD running the transaction log on a SAS SSD versus adding an NVDIMM, right? The NVDIMM intercepts those writes, and it can receive those write commands and acknowledge back to the application more quickly than the SSD alone. We've got 4x performance. So, wonderful marketing slide, but you want to see the data. And I'm also going to show you, as part of this, some really cool CPU utilization that you probably didn't know about. Okay? So while this is running, I'm going to talk a little bit about the configuration. This is a 24-core system. Right now, I'm running the transaction log on an NVMe SSD. And our CPU utilization is somewhere in the 60 to 63% range. Look at the chart on the right and look at the shaded area. Roughly half of the IOs are actually dedicated to the application, and this is the application interacting with the hardware. So most of your IOs, are dedicated to the application. Now, here in a second, we're going to run this same test on a single 8 gig NVDIMM, and I'm going to show you two things. I'm going to show you the CPU utilization, and I'm going to show you the IO that's dedicated to the application. Okay, here we go, it's starting up. CPU utilization went up to 100%, okay? What does that mean to you? You bought the processor, you've already paid for the full processor. We're going to give you technology now that allows you to get full use of your processor at 100%, but also look at the shaded area. We went from about using half of the resources to about 15%. Double benefit there. Full use of your CPU, and you get more cycles or less cycles dedicated to the application because the technology is that fast, it's able to use less. Okay. A couple more slides, then I'm going to turn it over to my colleagues. This is, we got to have our obligatory marketing slides in our technical sessions. We've been working extensively with DreamWorks. DreamWorks was one of our beta customers. They've tried out the technology, and of course, those of you not familiar with DreamWorks, they are a film company. They do a lot of the cool animated movies that you've seen coming out over the last few years. They've done things like Shrek and other things like that. They are essentially looking at using this technology for faster film rendering and analytics. I'm not going to read the quote up there, but I just want to show you that, we're not only touting this technology, we also have our partners and our customers advocating the use of this technology. And this is just the beginning, by the way. The 8 gig NVDIMM is our Gen 9 offering. Next generation, you're going to see larger pools of persistent memory, larger capacity, things that run at memory speed, things that run between memory and SSD. So we support up to 128 gig per server. You balance that on 2 sockets at 64 gig. We remove the bottleneck of SQL Server log write times. That's not a SQL Server problem, that's a problem of the hardware not being fast enough to keep up with the software. Persistent memory changes that. We increase the throughput and resource utilization. Let me just kind of end on this. I've been working with many operating system providers and many application providers in the industry. As the product manager, it's my personal assessment, Microsoft is way ahead of the game here. They've got the inbox driver in Windows Server 2016, and the changes they have made in Microsoft SQL Server have shown me that they really understand this technology. They are ahead of the game relative to their competition. So you as Microsoft customers can rest assured that this technology is real and it's available today. So with that, I'm going to turn it over to my colleagues. There you go.
So hopefully you will have had an illustration of all the work that we are doing trying to innovate and then have the right solutions whenever you need to accelerate your applications, well, specifically based on SQL Server. I want to spend some time also talking about how you can confidently run your mission-critical workloads with our scale-up systems. So I will talk specifically about the Superdome X, and I think I will start with a demonstration. So the thing is, the demonstration is recorded just because there are things that are taking time, and I wanted to show you some interesting stories talking about our collaboration and where we are going. So yes, let's play the video. That has been recorded off one of the machines with 4 blades. Those 4 blades has 2 sockets each. So that's an 8-socket machine. And one of the things is, I think you all know that Windows Server 2016 will be able to support up to 12 terabytes of memory. So then we want to show what's the benefit of having this type of thing. Okay, so just give me some time to start the video. And I'll talk more about what we are showing here. So we are showing different things. At least we want to show outstanding performance using in-memory technologies. Why 12 terabytes of memory? We are talking more and more about in-memory with databases. So of course, it makes sense when you have 12 terabytes to run a large data sets and then load part of them and use Microsoft SQL Server in-memory technologies. So as you can see, this is populated with 8 sockets. Each socket has 18 cores. We're running Windows Server 2016 and 12 terabytes of memory. SQL Server 2016 is just starting, so we do a fresh start. One of the reasons we want to do that, first, we show that we are using large pages, which makes sense when you have such a lot of memory. The second thing that we want to show is, even though there is 12 terabytes of memory, so of course there is a portion of it that's allocated to the operating system, and 11 terabytes, in fact, effectively, are allocated to SQL Server. So even though you have that amount of memory, it doesn't take time to allocate those 11 terabytes of memory for SQL Server. That's really some of the work we are doing. So of course, when you have such a lot of memory, we have embedded some of the technology so that if one of the bit becomes uncorrectable, so you have uncorrectable memory errors, the system is able to offline that memory and then continue to run. So the first thing we do is once SQL Server is loaded, we will do a query that's scanning 180 billion rows. I said 180 billion rows. And then it's doing some calculation in order to summarize the data. So that's typical analytics work that we can do. I told you this is 18 cores. So you can see, in fact, we have turned on hyper-threading. There are 288 logical processors seen by the operating system, and all of them are utilized. So that means, in fact, we have also worked a lot so that, well, you know, not only SQL Server can take advantage of the power that we are giving, but it's utilizing everything. The processor usage is not that huge because we are doing IOs. As a SQL Server has been starting up, there is some overhead just caching some of the data and then loading some memory structures. But in the end, after 3 minutes, we can see that the query has been executed. So now we want to show once the data is loaded into memory, and that's using column store indexes. Then if you run the same query again, it only takes 25 seconds. As you can see, in that case, all the processors are being utilized. And I think this is also what you have seen with the persistent memory. The next bottleneck that happens after the data is instantaneously accessed is the processor. So you need some processor if you want to do a lot of work, if you want to be effective. Of course, you can have also a few cores, and then with high speed in order to do your query. Now, we are doing another thing. We are showing how large is the table. The table is around 12 terabytes, and we are showing that this is really Microsoft SQL Server 2016 with the latest updates. And that's the size. The other thing that we wanted to show is there are, in fact, 120 SSD disks on which the database reside. And we wanted to show the type of throughput that you can get out of this configuration. The 4 blades have each 2 fiber channel adapters that connects to the disk. And that's well, something very common that we have with our users, our customers. Now we run the query when we clear everything that was in memory, just to show first how long does it take if you have the clean buffers, and then how large can be the throughput in this type of configuration. So I don't know if this is very visible, but effectively you will see that we are going up to 14 gigabytes a second in this particular configuration. We are showing that all the disks where the data is spread across are being used, and that's why we can get that amount of throughput. And eventually, the query will end after 1 minute and 15 seconds. So the key takeaways, of course, when you are running in memory, then that allows to run your queries in a very quick manner and then have instantaneous answers to your query. I wanted to show also something very cool at this time. It's just, well, the collaboration is not stopping. As you can see here, going forward, we have, well, that machine is capable of having up to 24 terabytes of memory. And then we are working on bringing this 24 terabytes of memory. This is the exact same demonstration, looking at how much time it takes to allocate the memory. And within 24 terabytes, it's around 3 minutes, whereas for 12 terabytes, it was around 2 minutes. I think we will end the video where it is, but I think what you have seen here is that, well, to get better insights, you have to have the right hardware. We are working a lot with Microsoft to provide you with the right solution depending on your case, your needs, your constraints, and all the factors that will influence the solution. So I want to just take a moment to talk about this Superdome X here. This is based on 18U rack, and it's based on blades. Those blades have 2 sockets. Those sockets are Intel E7 processors, so that's why we can bring a lot of reliability, availability, and serviceability function to the hardware, but up to the application stacks. And so the processors can be from 4 cores to 24 cores, depending on what you are doing. And we can have, in fact, up to 12 terabytes of memory. That's 1.5 terabytes per blade. The beauty of this box is that, in fact, we create what we call hardware partitions. Those hardware partitions will, in fact, be the server that will be running the operating system and the application. And in fact, we can start, the smallest unit is a blade. You can start with only 1 blade to create your partition. And if your business grows, you have more users, you need more IOs through your networking environment. Your database is growing, so you need more IOs within your storage, for example. You can add blades. You need more memory, and well, I didn't say, but you need also more memory and maybe more processing power. What you can do is just add a blade to this configuration, reboot the system, and then, well, don't reinstall, don't do anything. Windows is very clever and will understand that there is some new hardware and will be able to use it. So the thing is, for each blade, you have 5 different I/O adapters. 2 of them are LAN motherboards, but then you can have 5 channel adapters on the 3 other slots. And then it's built on our mission-critical experience for a year in the Unix world with RISC systems. So we have brought all that experience so that we have a chassis that monitors everything that's happening at the blade level, but also at the partition level, which I didn't mention. The hardware partition is also called NPAR, as you will see on the slide. And then eventually, so I have another slide that will talk about that, but everything is monitored before it gets to the operating system or the application, so that, well, you know, we try to fix any error so that the system continues to run. And if there is something wrong, we can't fix it, then we try to work around it, such as, well, you know, those uncorrectable memory errors, we work around them. We just offline the page that's bad. Microsoft Windows Server understands it and then also passes the information to SQL Server, which knows how to deal with that and will reload the data somewhere else. So we support partitioning. We must have partitioning. In fact, as I mentioned, a partition will be your server, and it's electrically and electronically isolated, which means your server running on, let's say, 2 blades can be rebooted, and the rest of configuration, let's say you have another server based on 6 other blades, you can have up to 8 blades in a chassis, then your other server, your other hardware partition will run. So then, well, of course, why is it good? You see so many resources, so many processors, such a lot of memory. It's just when you have to have faster transaction, when you have to use in-memory technologies and have large data sets, when you want to consolidate a lot of databases, this could be your solution. Now, well, just some words about the partitions. This allows to run in the box different types of workloads or different types of applications. They could even be of different versions of operating systems or different applications. So this is giving you some information about what type of mixture you can have. But I believe, of course, any case is a special case, and we have the solution that will fit. So here is a typical type of deployments we have with those machines. We can envision having a large partition with a large amount of processors and memory and IOs to run a mega instance of SQL Server for a large database. But we can also have a large instance of Windows Server running many engines of SQL Server, many types of, well, either many databases or type of workloads on the same box. That same mega instance of Windows Server can also run Hyper-V, and then several VMs with different versions of the operating system and different versions of SQL Server eventually. But also on the last slide, you can see that we can also envision having multiple partitions for different usage, each of them running a separate version of Windows servers and SQL Server. So just talking about what we have on this system that enables all this reliability feature. The portion that you see in gray is all at the hardware and firmware level. This is what we put in this type of solution to make sure that you have the right experience with your mission-critical application. So we have common components with our ProLiant browser. We have a fault-tolerant fabric. In fact, the blades are interconnected to each other over a very fast, high-speed fabric. And that's how, in fact, we can create our hardware partitions. Then we enable what we call firmware first, which is the firmware is looking at what's happening, and then if there is something wrong, try to attempt to correct it before it goes to the operating system so that we can continue to run. And then all the things that you would know. So the box itself has an error analysis engine, which monitors in on the fly, in real time, what's happening and tries to repair. Then, of course, we have Windows standard, Windows Server support, 2012 R2, but tomorrow 2016, with the failover clustering, and we integrate with all the features that you have on the standard Windows and SQL Server. So just have a slide that shows we have great customers. One of them is WB Mason, which you might know. They do Office product, well, they are Office products leader. And in fact, they were growing and growing, and they needed to have new hardware all the time to face this growth. Just because if you want to deliver the products that are ordered, first the order needs to be working, and then the trucks need to be delivering, so they need to have the right papers delivered in time and the right goods in the trucks. So they have chosen this solution, and they have achieved a lot of good things with that, such as accelerated the inventory accounting process from 36 hours to 8 hours, increase the number of batch requests per seconds, etc. So then just want to mention that if you want to have more information about those Superdome X, and Guhen will talk about the 3PAR. Well, of course, I mentioned all the things you have in the server, but then you have also the storage and retrieve the data from the storage with, for example, the 3PAR all-flash. We have reference architecture that you will find that talks about two different types of workload, the data warehousing, but also the operational analytics, where on the same box you can run your OLTP server system, at the same time query it with SQL Server new capabilities. So we do hybrid analytical and transactional processing on the same box. Now I want to hand over to Guhen to talk a little bit about 3PAR. Thank you.
Hello. Yeah. So welcome everyone, and you just listened to Brett and Lawrence talk about all the advanced technologies that HPE has on the memory, as well as the highly RAS-enabled Superdome X servers, right? Now I'm going to talk about the storage. That's our 3PAR store serve all-flash arrays, right? So the world is moving away from spinning media to flash storage, right? So I see like So before I go ahead, like, do you already have all flash arrays in your data center? Do you have plans to move into all flash arrays in the next 12 or 18 months? Okay, I think then you have, I think I have enough information for you to take home today and try it with 3PAR. Just a little bit of history, 3PAR was started even before NAND flash-based SSDs were available, right? We have our origins in our spinning disk only, right? And I'll come back to you and say why that is so important. So this is our portfolio of products. If you are starting to evaluate all flash arrays for your data center, and if you're looking for an entry-level array, and that's what we have here, it's the 8200 model. It's a sub 20K model that's available, and that can scale up to like quite a few terabytes, right? And you also have the highest capacity available with any entry-level storage, as low as like, and the overall cost will work out to be as low as $1.20 per GB, right? And then once you have tasted all flash arrays in your data center, it's like moving from a hard disk laptop to a flash-based laptop. The difference is very imminent and very visible. Now you want to migrate all your critical applications, so you need more capacity, more resiliency, and then specifically these critical applications are going to be things like SQL Server, right? Your databases, mostly it's going to be SQL Server or other databases, and that's when you need more capacity. And what more do you need when it comes to database is they do tend to have like 4 KB to 16 KB random IOs, or like an occasional, the logs do at 64 KB logs and all. So what is more important is IOPS along with a very low latency. IOPS alone does not mean that you have a better infrastructure. You need high IOPS at a very good latency, right? And you can look at that, the mid-range models there. Okay, this one can deliver up to 1 million IOPS at 0.6 microseconds latency, and that is really good for a database. The number of IOPS is actually so high, you can actually consolidate multiple databases on a single array and get the same or even better performance, right? And the maximum that you can go up to is that, and when you move out and when you want to really have an all-flash array data center, you don't want any spinning media for your production workloads, that's when you'll have to consider our 20,000 models. This is a 3PAR 20,000 model, which come with enterprise scale scalability as well as resilience or availability, right? So we promise 6 nines availability, and this one can scale from a 2-node controller to a 16-node controller, and you can address up to 24 petabytes, or you can use up to 24 petabytes of storage space there. All of this at the same level of performance, right? You can get 3 million IOPS still at 0.6 microsecond or less than a microsecond latency, right? So these are the arrays, like these are the actual value prop of 3PAR. Now, block storage is not the only way you are going to access storage, right? You will have applications that will need file access, and increasingly you are going to find yourself using applications that are going to need object access. Now, typically what you do is like you may buy another filer appliance and put that in front of your block storage, and then make that file service available to your applications. But with 3PAR, you don't have to do that, because file access or file persona is an inbuilt feature in 3PAR. You don't need any additional appliances. You just need to turn it on and then configure it for the size and capacity. Then you get file access for all your file-based applications, right? And similarly, it has an object store also. You don't need to go build an appliance using Ceph or any other object store products. You just have to turn it on, and then there is a REST API, and through which you can access objects on a 3PAR storage. So this is one array that scales from an entry level to the high-end enterprise class resiliency, as well as supports all kind of storage access with all kind of protocols: fiber channel, iSCSI, FCOE, file, SMB, CFS, and REST-based object access. Now that's your entire storage need served by one single box, right? So now obviously you might have a doubt about how does a single product line cater to an entry level and to an enterprise level, enterprise scale solution, right? So that is actually built and taken care in our hardware architecture as well as in the array's firmware, or what we call as our operating system for the array software. They have an architecture that can scale from a very small array to a very large array. And one of the key components of that is on the hardware, much like Lawrence talked about the crossbar fabric in Superdome X, we do have something called a mesh active fabric, which actually allows each controller to have a dedicated connection to every other controller. So there is no sharing. Any controller can talk to any controller at any time. And what that means is finally, all the LUNs, the capacity that you are going to export to your host, can be served by all the controllers, all the 16 controllers, right? And this mesh active framework is the one that helps us to scale. So when I say that, okay, all 16 controllers can talk to each other directly without even going through a common or shared bus, they have a dedicated connection, you might be thinking like, oh, that's going to be really complex to wire, right? But that's not the case. You don't need to do anything. With our 20K models here, you don't even get to see that. All those things is automatic, right? So with all the power, it is also very simple actually. In fact, the simplicity of this array is its power. Now, I'll go on to say like, okay, what can you expect when you want to use 3+ with SQL Server deployments or any other database for that matter. But for SQL Server, what do you expect? Like, first thing is we promise reduced or lower TCO, total cost of ownership. I'll run through a bunch of features that will allow you to realize lower TCO when using 3PAR with SQL Server, right? And then I'll take you through a bunch of features again that actually help SQL Server run better. You already saw HPE has technologies like the persistent memory as well as the highly RAS-enabled Superdome X servers. So there are performance improvements in the server, in the memory, and now I will show you the features that are available in our storage that is going to accelerate your database performance, right? So it is like you can have the highest, most powerful and fastest CPU and servers, but if your storage is a bottleneck, then you are going to be slowed down to that level, right? So it's really important to have a high performance infrastructure at every layer. And that's why it makes a lot of sense with the increased CPU counts and persistent memory, storage scale memory, all those things, to have all flash arrays for your storage, right? That's when you will get the most out of all your investment that you're going to make. And finally, I will talk about day-to-day things that you have to take care about, right? You have to make sure that your database is running all the time, you are protected sufficiently against any problems or any disasters or and you are compliant with any statutory requirements, that you have backups that needs to be taken as legally required. And you would allow to do all those things much faster and much simpler with less intervention. And I will tell you how our value-added solutions that is available from HPE can help you do that. Okay? So that's the three main topics that I'm going to cover. So let's see the TCO features, right? Okay. Oh, the slides are a little washed out here, so for you. So there are actually, is that how it appears on the slides? Okay, let it be like this here. So the first one is thin provisioning. So thin provisioning allows you to plan for growth in your deployments and not necessarily expend all the things that you expect over 5 years or 6 years, right? So if you have a database that is going to grow in size by 5 TB every year, it's not necessarily you have to start using that 5 TB or buy that 5 TB today itself. And that's what the thin provisioning helps. It helps you to over-provision than the actual capacity that you already have in your array. And you can keep on adding more and more as you grow. And that's one thing. Now, the important point is not just thin provisioning. You also need to stay thin, right? When you drop something from a database table, from SQL Server table, that space must be made available by the array, must be made free, or must be made available for additional allocations at the array, right? Otherwise, that capacity is still used, and you are not, you started thin, but you may not necessarily stay thin, right? So that's a very important point, and that's what 3PAR has a couple of technologies there, what we call a zero detection technology, and then there is a new SCSI standard implementation of unmap, which actually helps you, like whenever a bunch of blocks are not being used and an application doesn't need them, they can make that SCSI call, and 3PAR will disallocate and free up those blocks on the storage, right? So it's not just starting thin, and it's all about staying thin also, right? And if you have an application that is going to like zero it out, 3PAR can detect zeros. If it can see that like everything is going to be zeros, then it won't even write to the disk. Means it's not going to take space, any space in the array, right? So that's right away a lot of savings. Second thing is about sparing. Any disk array will have to reserve some capacity so that they can make sure that when some volume or some drive goes bad, the RAID-based layouts and the RAID algorithms can rebuild that failed drive data on a different place, right? So typically what you do is you will reserve 10% or 20% of your capacity in terms of drives for sparing, right? When it comes to 3PAR, we don't want you to allocate anything specifically for that. We don't say like, okay, reserve these 4 drives purely for sparing. Because in case of 3PAR, the sparing is done system-wide. We take a space in all the SSDs. So a small space in all the SSDs based on how much you want to be spared. And that has good advantage. That is because when some drive goes wrong, some drive fails, now you are not going to build, the RAID algorithms are now can build it much more parallelly, because the information that you need to restore is not always going to be stored in a single drive that was pre-allocated. It's now going to be spread across multiple drives, so these restore operations can also be much faster in 3PAR, right? This is what we call as system-wide sparing. And in addition to this, what we call as adaptive sparing, that is actually when you buy a SSD drive, when you buy an 1 TB SSD drive, the SSD drive vendor actually allocates 20% or 15% of the capacity for their own sparing that is inside the drive alone. So what we do is we work with our partners, our vendors, and we unlock those 10 or 15% that they have spared in their drives. We unlock a portion of that because we do have already sparing that is being taken care at the array level, right? So we unlock a half or more of the resource space in the drives, and we consume that capacity. So a simple 1 TB drive has more utilization and more space when it comes to 3PAR, right? And also about density, right? So all arrays will have drive chases, and like the 8200 model that you saw at the beginning, it has only 24 chases, right? Now, with that, if you want to build high capacity, now you need high capacity drives. And we are proud to say that we are the only company in the market today to support 7.6 TB SSDs and 15.36 TB SSDs. And please remember, this does not affect your latency, right? We still keep our latency promise with a higher density, which means we can get to do more with the less. And finally, I talked that the thing is about deduplication. I'm not going to dwell deep into that because deduplication is not going to help you much in a database scenario, but like this is one good feature that you might want to know, because if you are going to plan to use your 3PAR for file-based applications where you are going to talk about email, stores, and all this stuff, this one is a very good technology, and it can save you 4:1 level of deduplication, right? So those are the one features that give that. Then the other way to look at improving TCO is about consolidating, running multiple SQL Server applications on a same 3PAR. Now, this sounds very simpler, but when you try to do that, you will find that it is hard to do QoS, it's hard to do manageability, and it is not easy to move data across also, right? Once you put so many things on a single chassis. And that's why we have a bunch of features. There's a quality of service feature where you can assign, this is the level of bandwidth and latency that I need for each of my LUNs to a database, and that will be guaranteed and honored. As well as we have a multi-tenancy where you have like different departments who are trying to access the same array. You don't want them to have a different, you don't want all of them to have the same admin password and step on each other's toes. So the resources are still utilized parallelly, but the administration view is given, you can actually segregate based on administration views, and it's called virtual domains, right? And finally, what we call is federation. So eventually, you will end up with multiple AFA arrays in your data center, and what that means is you may have to move your application from one array to another array, and that is also taken care easily with the federation technology. So you can connect multiple 3PAR arrays together, and you can move volumes from one node to another node seamlessly. You don't need to plan that externally and all. You can just access it, move things across. So there's enhanced data mobility. So I'm running out of time, but I'm going to talk about the performance feature also. The first and key thing that I want you to take away from here is, in case of 3PAR, for every capacity that is exported to a host, that capacity is served by the entire array, all the resources in the array. If you have, let's take the example of the 8200 model where you can have 24 drives. So if you are now cutting out a 10 GB LUN out of that 3PAR, that 10 GB LUN capacity is going to be served by all the 24 drives, right? So you get better utilization, better performance, faster recovery, all those things, right? And not just at drives, we do that at controllers, CPUs, cache, everything is used for everything. There's no partitioning, right? And second thing, when it comes to database, actually, this is very critical. You may have like backups and stuff that are running. So backups can be like 4 MB IOs, and that may be large IOs, and that can actually start interfering with your production IOs, because you might have like large number of smaller IOs that can get stuck behind bigger IOs. So 3PAR has the intelligence, and it has very sophisticated algorithms where it can break down larger IOs into smaller IOs so that nobody gets stuck behind an IO, right? And we also make sure that the consistency of the larger IO is maintained, all this stuff, right? So these are some advanced algorithms that we already have inside our arrays, right? Over and above that, this is one of the biggest features of 3PAR, right? So for most of the compute-intensive tasks, where you have to calculate CRC checksums, where you have to calculate RAID parities, all these things, we can offload that to a separate ASIC that is built inside the 3PAR arrays. So apart from the processors that are going to serve your data, for computational purpose itself, we have a special chip inside our boxes. So that means the processors that are serving your IOs have more bandwidth and more time slots to handle those things, right?
Maybe move into Q&A.
Okay. So I'll just close with one slide? Yes. And finally, so these are, okay, there are many features. Not all the features are here on the slide, and I'm also not talking about everything that is there on the slide. There's a bunch of white papers that you can go back and refer back. We do have a separate white paper for SQL Server and 3PAR and SuperDOME X, where you can see all the things that we talked about today. I, Brett, and Lawrence, whatever we talked about, you can see more details about that. And these are certain things that we already have, persistent checksum, which will make sure that your data is secure from when it travels from one component to another component. it has a CRC check, and all those things are there. And yeah, those are the features. And finally, this is the day-to-day stuff that I wanted to talk about. One thing is what we call as Recovery Manager Central. This greatly speeds up your backup process. You can actually do 24 times faster backups and 3 times faster recoveries. With those software, it uses the snapshotting, thin snapshotting technology that is in thin 3PAR. And 3PAR has both synchronous and asynchronous replication. And the good news is we have these replications integrated with Microsoft's failover clustering. So what that means is, right, you can actually failover your application from one data center to another data center over a replicated 3PAR array, unattended, automatic. And that's the kind of DR automation that you really need to have if you are to really seriously protect your mission critical databases, right? And that's called a CLX cluster extension software that's available. And finally, just one point is the for virtualized workload environments, one of the things that you want to do is mobility across data centers. You may want to move your virtual machine from one data center to another data center seamlessly, right? Virtualization, biggest pull towards it is the mobility aspect of that. Now, we have a feature called peer persistence that allows you to replicate data between 2 arrays across several hundred kilometers. And not just that, you can actually move your virtual machine from one site, one data center to another data center, do an online migration of that, live migration of that, from one array to another array also. So these are some of the things, and thank you for staying back again and helping us finish the course.
Yes, if there's any questions, we can certainly stay after if you want to come up and ask questions, but we do appreciate you coming today. So we'll open it now for any questions.
And then maybe I think you can also come to our booth. We have our booth in the expo, and we'll be happy to answer any of your questions. I think we're just running out of time, and we thank you very much, and we hope that you had an overview of all the technologies we are putting together to enable the data-driven organization to have customers get better outcomes, turn their ideas into insights. Thank you.
Yeah, thank you, guys.
Thank you. So we are at booth number 1501. As soon as you enter the expo, you will find us on your right-hand side. We are on the first row. If you have any questions, please do come visit us.